All right, for this next one, we're going to have a little bit more work to do up front because as you can see, we do not have a 0 in our inequality. So the first thing we need to do is get everything to one side and get a common denominator so that we have a single expression with a 0 on the other side. All right, so I'm going to choose to subtract this over. So we're going to get x minus 2 over x minus x minus 4 over x minus 6 less than or equal to 0. All right, so now we need to go through the work of getting a common denominator so that we have a single expression instead of two expressions. Okay, so the least common denominator here, this doesn't factor, so the least common denominator will just be the product of the two of them. So I'm going to take this one, multiply it by x minus 6, and I'm going to take this one and multiply it by plain old x. Okay, so we're going to manipulate the numerators and the denominators. So it's all going to have a common denominator now of x times x minus 6. Okay, keep in mind it's less than or equal to 0 on the far right. Okay, so I have to do x minus 2 times x minus 6. So I'm going to have right here just x minus 2 times x minus 6. Subtract, I need to do x minus 4 times x. All right, so a lot of simplifying that has to be done to start off. All right, so let's keep going with that. So FOIL first, and you're going to get x squared minus 6x minus 2x is minus 8x plus 12. Distribute the subtraction sign with the x, you're going to get minus x squared and plus 4x. This is all over x times x minus 6. And I know it's still less than or equal to 0. Once I shorten this down a little bit by combining like terms, I'll get that all on there. Okay? So x squared minus x squared, those will go away. So this and this will be gone. Negative 8x plus 4x will be negative 4x. Then we have the plus 12 over x times x minus 6 less than or equal to 0. You can even factor a negative 4 out of the numerator if you want and make it negative 4 times x minus 3 over x times x minus 6, all less than or equal to 0. All right? So a lot of legwork that you have to do up front in order to get this problem to work out. All right, so I'm going to get rid of all of that. I'm going to rewrite the original problem, and then we'll go from there, okay? All right, magic, there we go. So now we need to go through, identify our domain restrictions, our numerator equal to 0, make our number line, test values, and identify do we want the positives or do we want the negatives. So let's start with identifying what are we looking for. All right, so we now have our function is going to be less than or equal to 0. So in order for this to work, we need the function value to be a negative value to get it to be smaller than or equal to 0. So we want negatives here. All right, so let's go through and write our domain restrictions and then write what makes the numerator equal to 0. So domain restrictions. So right here we've got x equals 0, and right here we've got x equals 6. Those are both open circles because they are domain restrictions. And then from the numerator, we have x equals, let's see, there's no variable in this GCF here, so that doesn't give us anything, but right here we're going to get x equals 3. Now because there's an equal to with the numerator, this is going to be a closed circle. Okay, so we're going to have a mix of open circles and closed circles on this one. All right, we're ready to make our number line, test values, and write our intervals. Here we go. So we've got 3 numbers to work with. 0, 3, and 6. Okay, nice easy numbers to work with. All positives, that's helpful. And now we want to start testing values. Okay, Remember, we're going to test them into the factored form. That'll be the easiest place to go. And then we can just focus on positives and negatives. Okay, so over here, I'm going to try x equals -1 and plug that in. So I'm going to get, when I do that, -4 times -1 minus 3 is another negative number divided by -1 is a negative, and then -1 minus 6 is another negative. So 2 negatives on the top is a positive, 2 negatives on the bottom is a positive, this is a positive overall, so this is a positive. You know what I just realized? I forgot to draw my circles. Silly Mara. So let's see, at 0 we've got an open circle, at 3 we've got a closed circle, and at 6 we have an open circle. All right, that's a little bit better. Sorry about that. So we got a positive here. Do we want positives? No, we want negatives, so that section does not work. All right. New test value. Now I'm going to test right here. So I'm going to try x equals +1 this time. Okay. So I'm going to have -4 times 1 minus 3 is a negative over +1 is a positive, 1 minus 6 is a negative, double negative up top is a positive, positive negative on the bottom is a negative. That comes out to a negative overall. So these are negatives. So we will want this section. That section will work for us. Okay? 2 more to go. Right here, let's try x equals 4, see what that gets us, because that's between 3 and 6. All right, so if I do x equals 4, I'll get, again, plugging into this over here, -4, 4 minus 3 is a positive, +4 is a positive, 4 minus 6 is a negative. So I get a negative divided by a negative, that comes up to a positive. These are positive values. We don't want the positives, we want the negatives. All right, last one. Something bigger than 6, so let's do x equals 7. So I'll have -4 times 7 minus 3 is a positive. And then on the bottom, I'm going to have +7, positive, times 7 minus 6 is a positive. So that's a negative divided by a positive comes out to a negative overall. Okay? So this comes out negative, which is what we were looking for. So we have 2 intervals that work again. And you may have noticed that a lot of times they seem to alternate between positives and negatives. And while that does happen often, it does not happen always. So you really do need to go through all of this testing work to see what works and what doesn't, because there will be some problems where it doesn't alternate positives and negatives, okay? So we just need a little bit of space to write our final intervals and we're done. Alrighty. So our first interval starts at 0, goes until 3, includes 3, so that's a bracket, does not include 0, that's a parenthesis, union with, and then the next one starts at 6 and goes up to infinity. Neither one of those are included, so they're both parentheses. Here is our final solution to this inequality. As you can see, it is a time-consuming process, but it's still a lot faster than graphing would be. All right, one more to go.